Hi, Brown. Welcome to the Student Brand live channel. So I hope it is clear to you all. Now I am going to discuss about light reflection and diffraction chapter. Completely we'll discuss about light reflection and diffraction. So how it will happen, everything. So make sure that you are noting down. So I'll be explain whatever I am explaining. So light reflection and reflection reflection and a refraction topic I'll be explaining. So just make a note of it. Notes also I'll give. So clear notes I'll give. So you'll get the notes, proper notes. So very important topic. So in the exam point of view also very important topic. Just check once. Light reflection and refraction topic. Reflection and refraction. Okay. So light reflection and refraction topic. So in this topic, what are the topics? What are the we can say index point of view? What we are going to discuss? What we are going to discuss? I'll sell. So first point I'm talking about plane mirror. So we'll talk about plane mirror. We'll talk about plane mirror. Okay. So first point we'll talk about completely about plane mirror. And next one plane mirror. So reflection part, in the plane mirror reflection part I'll talk. Reflection reflection part we'll discuss. Reflection part. And one more point. So in that regular reflection, irregular reflection also we'll discuss. Regular reflection and irregular reflection. So here regular reflection, regular regular reflection and irregular reflection. So in this regular reflection, irregular reflection. Okay. So angle of deviation, angle of angle of deviation will discuss. Angle of deviation. So these are very important. And plane mirror characteristics, nature of the plane mirror also I'll explain. So plane mirror, reflection, regular reflection, irregular reflection, angle of deviation, and one more point. So one more point is there. So few more points are there. So where we need to discuss related to questions point of view also we need to discuss those points also. I'll discuss. So each and every question will work out on it. So light reflection, refraction. So plane mirror, regular reflection, irregular reflection. Okay. So regular reflection and irregular reflection. So angle of deviation. So angle of deviation. This is very important. So related to this one, problem will come. So in the exam problem. So problem will come. Angle of deviation. So problem can be expected from this concept. So make a note of it. I'll explain one by one. Okay. So one by one I will explain. So you can see. So reflection. Coming to reflection. What is a reflection? Reflection is nothing but, so when the incident. So here I am taking when the object is. So here I am taking the plane mirror. Plane mirror. So this is a plane mirror. Plane mirror I am considering. So here I am considering this one. This is a plane mirror. This is a plane mirror, highly polished smooth surface. Plane mirror, highly polished smooth surface. So incident light ray is falling. So I'm taking this incident ray. So incident ray, this is incident ray. Incident ray. This will be the reflected ray. Reflected ray. So I'm taking the normal line. The normal I am considering. So this is a normal line. Normal line I am taking. This is a normal line. So this is a normal line. This is a normal line. So incident ray, reflected ray, normal line. Incident ray, reflected ray, incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Okay, so incident ray, reflected ray, normal line. So this is the undeviated I am taking. So initial direction of the incident ray. So simply we can say undeviated line. Initial direction of the incident ray or undeviated line I am taking. Okay. So here undeviated line I am taking. So the angle between incident ray and normal line. The angle between incident ray and normal line is called angle of incidence. Angle of incidence. So this is called angle of incidence, and angle between reflected and normal line is called angle of reflection. So angle of incident and angle of reflection, and the angle between reflected and deviated line is called angle of deviation. Angle of deviation. So first point you can see angle of incidence, second one is angle of reflection, and third one I am taking angle of deviation. Angle of deviation. Okay, so now you can see incident ray. The light ray which is incidenting on the surface is called incident ray. The light ray which is reflecting back is called reflected ray. The light ray which is undeviated line. So this undeviated line passing through the surface. Actually initial direction. This is the initial direction. So normally in homogeneous, see homogeneous medium, homogeneous medium and heterogeneous medium. There are two types of mediums are there: homogeneous medium and heterogeneous medium. In a homogeneous medium, light rays will move in a straight line because the properties of the particle present in the medium will exhibit same nature. Whereas here heterogeneous, so particle exhibit different nature. So a light will pass in homogeneous in a straight line. So if it is a straight line, so if you consider if the light ray moves in a straight line path, how it goes, how it passes. So that I am saying. So a light ray will move like this, undeviated line, undeviated line. So definition of angle of incident is angle between incident ray and normal line. So definition of angle of reflection is angle between reflected ray and normal line. And the angle of deviation, if you take angle between reflected ray and deviated line. So undeviated line. Okay, angle between reflected ray and undeviated line. Angle between reflected and undeviated line. Angle between reflected and undeviated line is called angle of deviation. Angle of deviation. So I hope it is clear to you all. Now I am taking one more. So here you can observe, right? So that is about angle of incidence and angle of reflection and angle of deviation. So laws of reflection. There are two laws of reflection are there. Laws of reflection. Laws of reflection. Laws of reflection. There are two laws of reflection. So what are those? First point is incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Lies on the same plane. And second point is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So this point is very very important. Make a note of it. This point is very very important. So incident ray, reflected ray, normal line lies on the same plane. Okay, so here angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. And now, so we can go with these are the two laws of reflection. Laws of reflection. Now, here you can understand one thing. Here you can understand one thing. Okay. So, what is that point is, if you are taking this angle, so this the angle, right? So it is looking like this. So see this line, complete line, you can like it, it appears like this. So this angle is how much? 180 degrees. This angle is how much? 180 degrees. So linear angle is 180 degrees. So in the linear angle, what are the angles are involved? So here angle of incidence, so angle of reflection, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. Okay, angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So here, we can take, I already discussed angle of incident equal to angle of reflection, right? So by using this formula, by using this relation, so how I can write? So observe carefully. Here, not only instead of angle of incidence, so I'm taking here angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. Okay, angle of incidence plus angle of incidence plus angle of deviation. So instead of angle of reflection, I took angle of incidence. Okay, so here even instead of angle of reflection, we can take angle of reflection. Angle of incident, we can take angle of reflection also. Now you can observe how it will be. So you can check once. I am taking here angle of two angle of incidence. Angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees, right? So angle of deviation equal to 180 minus 2 angle of incidence. So this is the formula. You can check it. So this is the formula, very very important formula. So I hope make a note of it. Make a note of it. Very very important. So you can check once. So angle of incident plus angle of here, angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees, because it's a linear angle. This is a linear angle, right? This is a linear angle. So here you can take from loss of reflection, angle of incident equal to angle of reflection, angle of incident equal to angle of reflection. So from this, so I am writing, instead of angle of reflection, I am writing angle of incidence. So angle of deviation equal to, the formula is 180 minus 2 angle of incidence. So instead of writing this one, we can write this also, like this: angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So like this also we can write. Clear? So do you have any doubts? If you have any doubts, you can ask. So otherwise we'll go to the next topic. Angle of deviation is completed. So the next we are going with the types of reflection. So I'm taking types of reflection. Types of reflection. Types of reflection. Okay, so what are the types of how many are there? There are two types of reflection. One is angle of incidence. Sorry, regular reflection, irregular reflection. One is First one is regular reflection. Regular reflection. Regular reflection. Second one is irregular reflection. Second one is irregular reflection. Regular reflection and irregular reflection. So what about regular reflection? Regular reflection, how it will be? Regular reflection. Regular reflection is nothing but, so I'm taking the plane mirror like this. La 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 la. So here you can see reflected beam is parallel. So this incident beam is parallel. So reflected beam also parallel. Incident beam is parallel. Okay, reflected beam also parallel. Reflected beam also parallel. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Clear? Any doubts? No doubts. So I'm going to the next one, irregular reflection. Irregular reflection. Irregular reflection we'll discuss. Regular reflection completed, so we are working on irregular reflection. So you can see here irregular reflection. So I am taking irregular reflection. So here irregular surface is there like this, irregular surface. So incident so incident beam is parallel but reflected beam is not parallel. Okay, so it goes in different direction. So check once. So check once. Clear? So irregular reflection. So I am taking here. So this is rough surface. Rough surface. Rough surface I am taking. Here you can see irregular reflection. So it is irregular reflect surface. Clear? So irregular reflection takes place on rough surface. Rough surface. So incident beam is parallel but reflected beam is not parallel. Incident beam is parallel but reflected beam is not parallel. So this type of reflection is called irregular reflection. Okay, so here you can see this uh, incident beam, this the reflected beam. So that is not parallel. Clear? So this is about rough on rough surface irregular reflection takes place. Then we'll go to the object and image. Object and image. So I'm taking this here I'm considering the mirror. I'm taking the mirror like this. Okay, so I'm taking here is the object I'm taking. So how many light rays are required to form the image of the object? Minimum 2 light rays. Minimum 2 light rays are required to form the image of the object. How many light rays? 2 light rays. Clear? Now I am taking. So one light ray I am taking like this. So another light ray I am taking like this. So we are extending those light rays. Here you can see. So I am extending this light ray. And here also I am extending this light ray. So if you are extending this one, the image will form here. Image, object and image. Here you can see, or one more diagram I am taking layer. Light rays are coming from different point. So here you can understand I'm extending these points. So I'm extending this lace. So here image will form. So incident ray, incident ray, reflected ray. So this is a virtual object, real image. Virtual object, real image. Here, virtual image, real object. Virtual image and real object. Virtual image. Virtual image. So here you need to understand one difference. So we have to understand one thing. The point of intersection of reflectors here, this the incident rays. These are the incident rays. So the point of intersection of incident rays is called real object. Real object. Clear? The point of intersection of incident light rays is called real object. Clear? Here I am taking this virtual image. Here is a virtual object. Virtual object. So we are extending this light rays. So these are the two light rays. The point of intersection of incident rays is called real object. So after reflection, those light rays will meet at one point here. This is a virtual image. Here you can see reflector light rays are directly meeting. So these are the this is reflected ray, this is reflected ray. So reflector light rays are meeting directly. So their image will form. That is a real image. So we are extending the incident rays. Those incident rays are meeting at one point. That is a virtual object. That is a virtual object. Virtual object. Okay. So we can conclude that from this. We can conclude that from this. So if object is real, so we can take like this object image. Object is real, image is virtual. If object is virtual, image is real. Very very important points. So make a note of it. So many times in the exam hall they'll ask these questions. Okay, so this is about object and image. Object and image. Next, so we'll go to the next topic. I'm going to the next topic. So image formed by the plane mirror. Characters of the image formed by the plane mirror. So we will discuss now. What is the nature of the image formed by the plane mirror? So we have to discuss that nature. So now you can see I am taking the plane mirror. This is a plane mirror. Okay. So I'm considering the object. This is the object. This is the object. Object I'm placing here. This is the object. One light ray I'm taking like this. How many light rays are required to form the image of the object? Minimum 2. So one more light ray I'm taking like this. It will be reflected. So here one more I'm considering like this, and here one more. So if you are extending those light rays, so those light rays are meeting at one point. So I'm taking here. Okay, so I hope it is clear to you all. This is the object, right? This is the object I am taking. So if you are taking object, so AB, this is A dash and B dash, AB, A dash, B dash, right? So first point I am taking, so in this case, so object is real, image is virtual, virtual, object is real, vice versa. Okay, so real and virtual, object is real, image is virtual, image is virtual. So object is virtual, image is real, vice versa. First point. And coming to the second point, object distance is equal to image distance. Object distance. Second point, object distance is equal to image distance. Object distance is equal to image distance. And third point, height of the object is equal to height of the image. Height of the object is equal to height of the image. Height of the object is equal to height of the image. And next one, we are going with the next one. It also shows lateral immersion. It also shows lateral immersion. Lateral inversion. So lateral inversion. What is the lateral inversion? The phenomena of converting of left side of the object appears to be right side. The right side of the object appears to be left side of the image. Left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. So even now you can see the letters. So mirror reflection. Okay. So we can consider, so B. So B you can take, it will be like this. In the mirror it will appears like this. Okay, different. So mirror reflection. This is the left, this is right. So it is appearing. So reverse. Mirror image. So I hope it is clear to you. So that is a reflection. So here are questions, coming to the questions. So I'll ask one question. So anyone knows the answer, you can tell. What is the cause of lateral inversion? Cause of lateral inversion. Anyone knows the answer? Cause of lateral inversion. Cause of lateral inversion. Anyone knows? Just let me know. Cause of lateral inversion. A smile. Anyone knows cause of lateral inversion? No one. At least tell something. So I explained just now, right? Till now. Cause of lateral inversion. Object and image both are facing each other. That is only cause. Object and image both are facing each other. So that is only answer. And next one. What type of image is formed on the plane mirror? Virtual image. On cinema screen, real image. And difference between real image and virtual image. What is the power of a plane mirror? So I'll ask a simple question. So try to answer it. What is the power of plane mirror? I'll just ask. Power of plane mirror is 0. Power is 0. Answer. This is the answer. Okay, one more question shall I ask? So what is the value of speed of light? 3 into 10 power 8 meter per second. Okay, paraxial rays and marginal rays we have to discuss. So paraxial rays and marginal rays. Generally, the rays which are very close to the principal axis, those are called paraxial rays. So I am taking this concave mirror. So pole, focus, center of curvature. If the rays are very close to the principal axis, okay, so this rays. So here if the light rays are incidenting, the rays which are very close to the principal axis, those are called paraxial rays. The rays which are away from the principal axis are called marginal rays. Okay, so paraxial rays. Second one, marginal rays. The rays which are away from the rays which are very close. So these rays are called paraxial rays. So these far away rays are called marginal rays. Okay, so that is about today class. So we'll see in the next class few more points. Okay, so if you like this video, do like, share and subscribe to Student Independent. Thank you.